digital signature and hashing technique using the Cryptool2 simulator. Uh, Digital signature, we know that it is essential for the sender's authentication, for data integrity, and for non-repudiation of the data. So this digital signature can be simulated in the Cryptool tool. So I'm using the text inputs, outputs, RSA key generation, and blind signature verifier and blind signature generator to generate the hash value, random or arbitrary number, and the signature. And then the fourth experiment, hash boolean output, gate AES SHA-256 HMAP string encode stream comparator and all I have used to check the data feeder is whether tampered or not. Hashing has been used. So we know that Cryptool is a latest technology. This is the tool actually. We have the basic templates and all, earlier templates and all here itself in the workspace. So this blind signature with Pioneer algorithm is the default one. I have created on my own workspace for the digital signature with the help of the RSA algorithm and then with the blind signature also. So we know that Cryptool is very essential for visualizing the cryptographic operations, functionalities and all. So it gives a very good GUI so that we can do any analysis for the older cipher algorithms or for the newer modern cipher algorithms also. So here it's just mentioned the more classic cipher algorithm like a Hill cipher, Playfair and all. Modern ciphers includes the Blowfish, DES and then RC4, those things like a Rabbit and all. The latest modern ciphers, hash functions, cryptographic protocols, everything has been mentioned. With the tools I have dragged and dropped these things. So this is the input message. My name I have given my name as the input message as Geetaji. That is my student message. I want to send the same message to my professor, network management professor. The same name has to be outputted. So I have designed in such a way. That to transfer the data, I have used the RSA key generator. We know that RSA is nothing but a public key or asymmetric key cryptography, which is very essential for the transmission of data securely. So in this we know that in the RSA we will be having the two prime numbers normally, where both of them must not be equal, and we know the phi of n is equal to p minus 1 cross q minus 1 and n is equal to p cross 1. So we know the public key and private key to be mentioned, e comma n and d comma n. So encryption is c is equal to m power e of mod n and m is equal to c power d mod n. So in this, likewise this RSA, this prime numbers are actually, these both prime numbers are kept a secret. Only messages are encrypted by anyone, but the public key only anyone can decode the message. Whoever knows the prime number only can decode the message, but anyone message can be encrypted by anyone. That is the scenario in the RSA. So coming up for the BS is nothing but a blind signature. We know that it is here normally the message is blinded or disguised before it is getting signed. So once the blind signature is publicly verified against the original message, we can unblind the message in a regular digital signature format itself. So in this Cryptool it supports both Pioneer and RSA. Pioneer is nothing but Pioneer key generator or RSA we can use it, but here they have used the template Pioneer, so I have used the RSA here. And coming up for the Next one is blind signature verifier. So in the input I have fed my 8-letter word. After that, in the RSA key generator, we can generate the prime numbers and set the ranges also, generate prime numbers or enter prime numbers manually, which is for our convenience. We can do the encryption or decryption, whichever. Here I'm going for the generate prime numbers in this range itself. So in the BS generator, I have set the hash algorithm to be none. If we want, we can set it to any of the SHA, SHA-256, anyone or like that. And I am using the signing algorithm as RSA and not as Pylor. And then security level is set to 500. And then coming for the binding blind signature, as I am using the RSA, I mentioned RSA. If Pylor is used, Pylor is has to be mentioned. And then converter is for the whether we want to convert it as a string in the UTF form, A8 format or an ASCII format, whichever format we are required, we can do it. And the big endian or little endian likewise, and the digital grouping size and the digits of in the formats. If we want to know specify one of the formats in the, we can specify, or in the string or byte intervals we can specify the digits. These are the normal things. This is the text output, which is the thing we want to actually get the final output. If we are not having the correct output in the here, as the input feeder, we can find out in the verifier with the warning messages and the wrong messages and all. It will be displayed like in this place. So here I have fed my input to the BS generator, and the RSA key generator has been fed to the inputs of BS generator. Once they have fed, the blind signature also gets the input from RSA. So I am using the dummy solution for this before it gets into the actual blind signature verifier, which is mentioned here. This is the blind signature verifier. So before that, I'm having the dummy thing. So if my message is this one, and hashing and random number key, that is arbitrary number, is generated, and the signature has been mentioned here. So whichever I have typed here, once the blind signature verified with the inputs whichever given, the prime numbers are only decode. The person who is having the end user is actually I'm mentioning as my professor. So actually, so professor decrypted signature is one mentioned here. So whichever I give the input, it must run it. So we can play the message accordingly. So I'm minimizing it. So I'm giving my input. Earlier I have given my name. Now I am giving this network management. In a single line I have written with the 18 characters. Even the space has been calculated. So I'm going to play my output. Here already written value is there. Now I'm going to execute it. So I could get the output on the receiver side also. The next person also having the professor side answer also network management. Same data has been simulated. So we can find that our data is not digitally signed with the help of the blind signature with the use of the RSA key generator and the converted using the converter in the string format itself. And we are done with our third experiment. Now we are going for the hash. Actually, we go for the hashing technique to have the authenticity and integrity over the data. Whenever we are having the data of same value, then we have to validate all the data with a fixed length alone to make and find out the values easily. So actually hashing or so hashing will be like converting the original information uh, into a key with use of a hash function, and it gives more security when comparing to the encryption, because we can't retrieve the exact information initially, whichever we feed it, we can't be getting it or retrieve it even with the hash key which we are having. So when comparing to the encryption, we say hashing is the better thing for security purpose. So it is majorly having the original value, where with the use of the hash key it has been shortened with the fixed length. So I have demonstrated the experiment here, where we are having the HMAC. HMAC is nothing but initially the sender will be having a message with a key, and also MAC algorithm, that is message authentication code, is fed, and the same data has to be placed with the receiver side also, message and key and a MAC algorithm and MAC message authentication code. When both the sender and receiver's message is matched only, the data can be transferred. So it is a very better secure authenticated way over the message from the sender to receiver. So in this scenario, I initially started in the workspace with the text input. Like this is my text input, and I'm having the two text input for and I have typed a network and with the AES for the encryption. With the 256-bit I have mentioned, and the chaining mode has EZB. We know 5 modes: CBC, counter mode, electronic code mode, everything has here. Output feedback mode, everything is here. Whichever we needed. Paddings, if we needed, that is padding means attaching. If we needed, we can set it like none to 1 to 0 padding or PKC, anything we can do it. And then here I am having the SHA function, which is 256 I have mentioned. And then coming for the HMAC. In the HMAC, I have done my hash function to be message digest 5. Whichever we required, SHA-1, SHA-256, anything, we can mention it. I have mentioned my message digest 5. And then I have the string encode, where the format is set to be 8 and text format. So here I'm, in order to have set the action over the AES encryption with the 256-bit, I will be adding the SHA algorithm to this workspace. So once the encryption, then it is added to the SHA function. That is which is of 256 has been set. And then for the decryption purpose also, I'm setting the key size of the 256 only here. Here also 256 for decryption, padding also 0, and ECB only chaining mode I have used. So after that, here also I have mentioned with the SHA algorithm, which is of 256 again. And then I have added the string coder and the text output 5 here, and then provided a plain text message into the inputs and all wherever needed I have inputted. And I also defined the pre-shared key as NIS. For the network, I have defined the key for NIS. So and then I have initially done this process, and then I have placed the HMAC to the string comparator, and then establish the connection to it also. And then I have, after connecting the stream comparator to the HMAC, I have added the boolean output and set it as a true when we are having the Boolean return value is true means then we can this red lamp will be cloned into green. It meaning that integrity is maintained over the message, and also added the gate to the comparator, to the stream comparator. Then AES encryption also, this encryption also linked to the gate, and AES decryption also linked to the gate. And then I'm setting the gate value to be true, and then once we run the simulation we are able to have glow the green lamp, so that our AES and the is encrypted and decrypted and given the original value message. If not, the lamp will not glow green. And then we can understand that the message has been violated or tampered. So this is the same, whichever plain text initially original text we have fed it, that must be got into our text output with the same message. So here the same message net I have been. Now again I run with a different input as professor. So I have fed the input as professor now. So I'm going to run my output. Yes, it is done. We can verify our answer. Yes, professor. In the text output also, I have got my output as professor. Yes, thus we are finished with our 2 of the experiments. Thank you, sir. Thank you for your time and consideration. So it is not only with this, but the NS2 simulator also we can do it. But I have tried with the Crypt2. Crypt2 version 1 is there. It is a straight away thing, which we know. Thank you, sir. Thank you for your time and consideration.